Alright guys, this first section in chapter 3 is all about different ways to solve systems of equations. So systems of equations, we're going to write down an actual definition, but a lot of times it works better to look at an actual visual. So if you see example 1, example 2, all throughout the page, these are examples of systems of equations. We know what a linear equation looks like. That's that 2x minus 5y equals 11. These are all examples of equations that are either in standard form or pretty close to it, because remember we did have a couple of restrictions on standard form. And we've got 3 different ways that we're going to learn to solve them today. So, system of equations, our first definition here, a system of equations is 2 or more equations with the same variables. So now, today's lesson, we're going to be working with 2 equations. In the future, we will be working with more equations. Alright, so this first one right here, solve each system of equations by using a table. So using a table is kind of the least effective way, but we're going to go ahead and do it anyways. So for these ones, it's most helpful to get them into slope-intercept form first, because you want to have the y by itself. So let's start with the first one. First one, you subtract 2x from both sides. So it becomes negative 5y equals negative 2x plus 11. And then divide both sides by negative 5. And when we divide both sides by negative 5, on the right-hand side, that means we divide both of those things by a negative 5. So on the left, we get the y by itself equals, and then we have a negative 2x. That gets divided by a negative 5. So the negative 2 divided by negative 5 gives me a coefficient of 2/5 in front of the x. It comes out positive because I have a negative over a negative. And then 11 over negative 5 gives me a negative 11/5. So that is my first equation in slope-intercept form. It's kind of the first step there. And then same thing with the next one. Start by adding 3x to both sides to get my 4y by itself. And then I get 4y equals 3x minus 13, and then same thing, to get the y all by itself, I am going to divide both sides by 4, and when I do that, that means I divide both of the terms by 4. So I have 3x divided by 4, so the 3 over 4 will be my coefficient in front of the x, and then 13 over 4 minus 13 over 4. Alright, so there are my 2 equations. I've got them into slope-intercept form, that's the first step, and then I'm going to use the table. I'm just going to plug in some different values of x and then figure out which one works. So for this one, there are a couple of different options here. We could try, just plugging in like 0, 1, 2, 3 to try to make something work. We could start with negative values, positive values. A lot of times it's really just a guessing game to make these work. So for this first one, let's do like 1, 2, 3. Okay, so x is 1, 2, 3, and then we've got 2 different values for y. So first I'm going to do the 2/5 x minus 11/5, and then I'm going to do y equals 3/4 x minus 13/4. Okay, so now let me show you how we would use our calculator to come up with these. Okay, so for each one of these we've got this equation. We're going to take turns plugging in values. So this first one, for instance, is 2/5 and then times 1, that's where I'm plugging in my 1 for x, and then minus, this is an 11/5. So this I get negative 1.8 for y. Okay, next I can go into the same equation. I can just arrow up right here, hit enter to paste it, and then arrow over here. This time replace the 1 with a 2, and then I get negative 7/5. Whoops. So always hit control enter if you want a decimal. So negative 1.8 is what I get for 2. Arrow up again, hit enter to paste. Replace the 2 with a 3 for the last value on this table. Hit control enter to get a decimal, and I get negative 1. And let's move over to my next equation right here. So then I have fraction, so hit Control divide, 3 over 4. First I'm going to replace the x with a 1, and then minus fraction again, 13 over 4. So hit Control, Enter. I get negative 2.5, so that's not it. Then arrow up, copy, paste, delete, replace this next one with a 2, hit Control, Enter. I get negative 1.75. That's not it. So one more time, and then we're going to go with an alternate route if this doesn't work. Delete the 2, replace with 3, Control, Enter, and I get a negative 1. All right, so here's what I just came up with here if we look back at my table. When I plugged x equals 1 into both of these equations, I got 2 different y values. So this is not the solution. When I plugged in the 2, I got 2 different y values, so that's not the solution. When I plugged in this x value, I got the same value. I got the same y value. So that means they intersect, they have the very same point. So 3, negative 1 is the solution, and the solution is the ordered pair that satisfies both of the equations. So 3, negative 1 would be my solution. All right, so that's one way to actually kind of write out the table on your own. Of course, you can see the flaws in this method is that it's going to take you a while to guess. The only reason I had us do 1, 2, 3 is because I knew the answer was going to happen at 3. You don't go into this method knowing the answer. So let's do a slightly different method for this table. I'll walk you through how to use your calculator to do these. So with these ones, same first 2 steps. We're going to do, either addition or subtraction of the x term and then divide to get the y by itself. So this first one, I'm going to subtract 4x from both sides. So this becomes 3y equals negative 4x minus 17. And then to get the y by itself, I'm going to divide both sides by 3. And remember, just like the ones up above, when I divide both sides by 3, I divide both of those terms by 3. So my coefficient in front of the x is going to be negative 4 over 3 times x, and then I have negative 17 divided by 3. So that's my first equation. Okay, second equation. Add the 7x to both sides. So this thing becomes a negative 2y. Don't forget that there's still a negative right there in front of the 2y. Equals 7x plus 20. And then to get the y by itself, I divide both sides by negative 2. So my equation becomes y equals, I divide the 7 by negative 2, I get negative 7 halves times x. I divide the 20 by negative 2, and I get a negative 10. So those are my 2 equations. Okay, so my solving method is still going to involve tables, but I'm going to have you guys walk through this on your calculator. So either open up a new document or add a page to your current document. Either way, we are going to add a graph page. So we're going to do this all by graphing. All right, so I want you to make sure that you're following along with your calculator. I want you to actually do this yourselves. If that means you need to pause the video, rewind the video, whatever, please do that. So first we are going to plot this first equation right here. So f of x, remember, is just a fancy notation for y. So negative, then hit your fraction key to put in the 4/3, then type in your x, and then minus, hit the fraction key again to type in your 17/3. So when you have that equation typed in, then press enter. It's going to give you a graph of our first equation. All right, and then to enter in another equation, the second one, hit tab and then do the same thing. So negative, hit the fraction key to enter in the 7 halves, and then x, and then minus 10. So that is my second equation. So hit enter. All right, so what we're looking for, and I did this so we can get kind of a visual, is we've got this one point right here. If you're picturing 2 lines, the most they can ever intersect, I mean, unless they're the exact same line, which we'll talk about that, but if it's 2 different lines, they only intersect at one point, and that's the point that we're trying to find. So to do our table, pay attention to this command, rewind it if you miss it. You're going to hit the control button, the blue button right here, hit the control and then the letter T for table. So hit control and then the letter T for table, and it will open up this nice table for you with different values. So it looks like it's definitely a negative x value where these intersect. So just arrow up, and you're going to scroll through some different values. So if we look, now of course this is slightly off the screen. Oh, there we go. Okay, so this is what we're looking for. We're looking for a place where I've got the exact same y value. So when I plug in negative 2 into the first equation, I get negative 3, and into the second equation, I get negative 3. So that is my solution. So from a graphs page, you hit Control and then T. Okay, so when we did that, we got the table, we kind of searched around, we found that there was one ordered pair where they intersected, and that is going to be our final answer there. The ordered pair, -2, -3. All right, so the next one we're going to solve by graphing. All right, so solve each system of equations by graphing. So we're going to start this one again by getting into slope-intercept form. So this first one right here, move the 4x over. So subtract 4x from both sides. This thing becomes 3y equals -4x plus 12. Divide both sides by 3. And so for my first equation, I get y equals -4/3 x plus, and then the 12 over 3 gives me 4. Okay, and then for my second equation, I am going to add 6x to both sides. So I get 4y equals 6x minus 1. And then I finish it off by dividing both sides by 4. Okay, so first I get y equals, the 6 over 4 reduces down to 3 over 2 in front of the x, and then minus 1 over 4. So here's my second equation. This is what I got for my first equation. I'm going to solve by graphing. And so in order to do this, I am going to look at a graph. So back into my graph. So add a new page, hit Control Doc to add a new page. I'm going to do a graph page. Just like before, I'm going to plot these two equations. So here's my first one. I'm going to do a negative, control divide, type in my 4/3 times x, and then plus 4. So that's my first equation. And then hit tab again, enter in my second equation. So control divide, I can do 3 over 2, and then times x, minus control divide again for 1 over 4. All right, so those are my two equations. Now, our goal is to see where they intersect, so we're going to turn it into graph paper to make things easier for us. So again, I really want you doing this on your calculator so you can learn. So hit menu, and then we're going to go into the view menu, number 2. And then in the view menu, we have this grid menu right here. So hit 6 for grid, and we're going to add a lined grid. And that will turn it into graph paper. That will make it a lot easier to see this point of intersection. So this point right here, the x-coordinate seems to be 1.5, and the y-coordinate is 2. So my intersection point is 1.5, 2. All right, and now for part B, I'm going to show you yet another way. So let's hit Control, Add Page, and add a graph page. Now there's a special way that we can enter in standard form. So hit Menu to enter in standard form. This is a lot of calculator work, so I want you doing this with me. Hit number 3 for graph entry. And then you can tell it what type of equation you're about to type in. So number 2 for equation, so hit the number 2. You're going to enter in a line, so hit number 1 for line. And we're going to enter it into standard form, which is that last one right here, so hit 3. And then it kind of opens up this blank standard form. So I have in front of the x, I have an 8. Make sure you're reading this equation in the right order. So in front of the x, I have an 8. And then tab, in front of the y, I have a -3. And then hit tab, and then my constant on the other side is a 36. So hit enter, and it'll give us our graph without even having to switch it into slope-intercept form. So many, many different ways that we can do these. Okay, then hit tab one more time, and it'll still be in standard form unless you switch it back. Kind of makes it a default setting for the time being. We've got a 6 in front of the x, so type that in for your coefficient. Then hit tab. Now we have nothing in front of the y, which remember is technically a 1. So we're going to enter a 1 there. Hit tab again, and then the number on the other side is a -21. So hit enter. There's my second graph. Now this one is a little bit of a problem because we can't see where those two graphs are intersecting. So we're going to hit menu, window zoom, we got to zoom out. So hit number 4 for zoom out, and we're going to move ourselves down. There we go. Okay, so see how I kind of moved my zoom out key and kind of zoomed in around where I thought that intersection point would be. So hit escape, and then hit menu. We're going to do the grids again. So menu, view, grid, and then add the lined grid. And then that way we can see where they intersect. So this point right here, this is going to be annoying to count, but that x value is a -1. And it looks like the y value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, -15. So the x value is a -1, the y value is a -15. All right, so two different ways to solve by graphing. So let's flip and look. We've got another method to work with here. Okay, so consistent solutions and inconsistent solutions. I've got a couple more definitions to write down here. So system is consistent if it has at least one solution. Oops, this should be these should all be systems. Sorry, all of these words right here should all say system, not solution. So this is a system with at least one solution. Okay, an inconsistent solution is a system with no solutions. Okay, so this is system, system, system. An independent system has exactly one solution. And then a dependent solution, dependent system has an infinite number of solutions. Okay, a system with an infinite number of solutions. All right, so we want to graph each system of equations and describe them. So we're going to do that in our calculator. So we can go into even just the current document. One thing you can do, let's just add a new page, I guess. So add graphs page. We're going to plot these two. So remember how to plot them in standard form. Hit menu. Number 3 for graph entry. Number 2 to tell it what type of equation we're going to enter. Number 1, because we're using lines, and finally, number 3 for standard form. So the number in front of the x is a 6. Hit tab. In front of the y, we have a -4. Hit tab, and on the other side, we have a 15. So hit enter. There's our first equation. Then hit tab again. We're going to enter in our second equation. So I type in a -6 for x, hit tab, type in a 4 for y, hit tab, and then there's an 18 on the other side. So hit enter. So what happens here, and hopefully you can get a good view of this just from your calculator screen, is that those two equations are parallel. All right, so the directions said to graph each system of equations and describe them. So what's happening here is that these two lines are parallel. They're never going to intersect. All right, so the two lines are parallel. So by describe them, I mean we've got these 4 words for the system up above. So parallel lines, it's not a consistent system because they don't have any solutions at all. Oops, which means it is an inconsistent system. It's got no solutions. So this is an inconsistent system. So it can't possibly be independent or dependent because those fall into the category of consistent systems. All right, let's graph this second one. Okay, so if I hit tab and arrow up, you see where these boxes are checked? I can uncheck the box and then it'll get rid of that graph. So you can arrow up again and uncheck this box. It'll get rid of that graph. So then arrow back down, we can put in some new ones. So the first one we're going to put in, there's a -4 in front of the x, hit tab. There's a +5 in front of the y, hit tab, and there's a -17 on the other side. So hit enter to graph that first one. So there's our first linear equation. Second, so now hit tab to enter in a new one. I've got a -4 in front of the x, hit tab. I have a -2 in front of the y, hit tab, and there's a 15 on the opposite side of the equation. So hit enter. So I've got two totally unique equations. You can see that they're going to intersect in one point right there. And so those two, they intersect at one point. So these graphs intersect at one point. So it is a consistent system because there is at least one solution. They intersect in one point. Because it's a consistent system, it's not going to be an inconsistent system. And then between independent and dependent, we say it's an independent system because it has exactly one solution. Okay, so for all of these things, we've got a couple pictures that we can set up. So we've got some different linear systems. We're going to draw some pictures. So 3 different ones here. You can either be consistent and independent, or consistent and dependent, or just totally inconsistent. All right, so the first one will be consistent and independent. The second will be consistent and dependent. And then the third option is that it's inconsistent. And we'll sneak that one at the end there. Okay, so first one, consistent and independent. Consistent means it has at least one solution. Independent means it has exactly one solution. So what's going to happen there is it doesn't matter what your 2 lines look like. But you've got one line, and then you've got another line, and they intersect in exactly one point. I know those kind of came out perpendicular. They don't have to be perpendicular. The only thing is that you've got 2 separate lines. They are intersecting lines, and you've got exactly one solution. If something is consistent and dependent, set up your coordinate system here. What ends up happening with this is that you've got a line right here. Should probably have arrows on these. And then in order to have an infinite number of solutions, what ends up happening is that when you graph the second one, it's actually the exact same line. Like one line got graphed right on top of the other. So they end up being the same line. That means they have infinitely many solutions because they are constantly intersecting each other over and over and over again because it's the same line. And then inconsistent means there are no solutions. The only way to have no solutions is to have 2 parallel lines. So we might have a line that looks like this, and then a line that looks like this. They're parallel, they've got the same slope, they're going to run right next to each other without ever crossing. All right, so we're going to call it right there for the first lesson.